Hello students and welcome to our class today. Today we are going to talk about compound interest as the second method of computing interest. In our previous class, we talked about the simple interest, whereby we said simple interest, it is the interest that is calculated on the principal amount only, that is the amount that is borrowed or the amount that is invested. When we come to the compound interest, it is actually a type of interest whereby interest in the previous year, it is used in calculating the interest in the next year or the subsequent year. So what I mean is this. If, for example, the principal amount is 10,000 shillings, then the rate of interest is at 10%, and the time, which is our n, is 3 years. You are told to calculate the compound interest for each and every year. So you need to come here and calculate the compound interest for year one, which is going to be the same as the 10% times 100 times 10,000 rather, times 10,000. So you'll find that the interest is just going to be 1,000 for the first year. When we go to year two, the principal or the amount that we are going to calculate our interest on is going to be the 1,000 interest plus the 10,000 principal. So you'll find that the interest is going to be 10% into 10,000 plus 1,000. So this 1,000 is added to the principal so that now you can get the amount on which to calculate the interest in year two. So you realize that this is going to be 10% times 11,000, which will be actually 1,100 shillings, like that. So when we go to year three, the interest will be based on 10% times 10,000 plus 1,000 plus 1,100. So we normally include the interest for the previous years to the principal so that we can calculate the interest for this particular financial year. You will find that is going to be 10%. We multiply by, this is going to be 12,100. So the 10% of this amount is actually 1,210. That is going to be the interest for the third year. If, for example, we were to go to the next year and maybe calculate the interest, that is year four, you will find that the interest would be 10% times 10,000, which is our principal, plus 1,000, which is the interest for year one, plus 1,100 for year two, plus 1210, plus 1210, which is the interest for year three, which you'll find that this one is going to be 10% times times this is going to be 11 1,100, 13, just a minute, this is 10,000, 11, 12, 100. So this is going to be 13,310, like that. So you will realize the interest for this year is going to be 13, that one, like that. So we go adding the interest for the previous year as we calculate the interest for the subsequent years. And actually, this is now what we call the compound interest. So with the compound interest, we don't calculate the interest on the principal amount only, as the case for the simple interest. In this case, the interest is calculated on the principal amount plus the interest for the previous years. You will realize that it is going to be quite cumbersome or tiresome to calculate the compound interest when the time period is very long. If, for example, you are calculating the compound interest for maybe 20 years, going up to year 20 using this approach might be quite tiresome and a long process. To make our calculation easier and faster, we have got what we call the compound interest formula. So allow me to give you the compound interest formula, which is actually used in computing the compound interest a bit faster and actually simply. So this formula says that amount after n years is normally given by the principal into 1 plus the rate, which is in percentage, times n. Remember here, amount is normally denoted by A. A stands for amount. So principal is normally denoted by P. R stands for the rate of compound interest, and N is for the years, number of years that is. So this formula can be modified to be amount is equals to principal into 1 plus R percent power n, like that. So this is how we can be able to get that amount. So in our case there, we can be asked, or we can be interested to get the amount after 3 years. We can get the amount after 3 years. So the principal was 10,000. The rate we were using 10%, and we say we want to know the amount after 3 years. But first of all, allow me to come here and have that amount so that we can be able to compare. So after 3 years, if we were to get the amount, the total amount will be equal to the 10,000 plus 1,000 for year 1 interest plus 1,100 for year 2 plus 1,210, which we actually found it to be. Let me confirm. 13,310, which actually comes to 13,310. So let us see, if we use the compound interest formula, are we able to get 13,310 as the amount after those years? So this is going to be the case. This is going to be the case. So we can come here and we say amount will be equal to the principal, which is the amount that we started with, into 1 plus the rate is 10% power 3, because we are talking about 3 years. So you'd find that A will be equal to 10,000 into 1 plus 10% is the same as 0.1 power 3, which will be equal to 10,000 into 1.1 power 3, which will actually be equal to what? Let us raise 1.1 power 3. 1.1 power 3 gives us 1.331. So if you multiply that, is going to give you 13,310. That is actually going to be the amount after 3 years, given that we are talking about the principal of 10,000 and the rate of 10%. You would be able to realize this amount is the same as what we calculated, here, 13,310. So the compound interest is just straightforward if we use the compound interest formula, and actually you don't have to go a long process. But note, in this formula, whereby we said A is equals to P into 1 plus R percent power n, you can be told to calculate anything. You can be told to calculate P, You can be told to calculate R or N. You can be given a question like this where you are told that an investor earned a total of 120,000 after 4 years. That is to say, an investor invested a certain amount of money, and after 4 years, his money had accumulated to 120,000. So the accumulated amount of money, it is the amount. The principal, the amount that that investor invested, we don't know. But we are told the bank where this money was invested pays a compound interest rate of 12%, and it took 4 years for this amount to accumulate to 120. So this person invested a certain amount of money, which we can actually say it is X, in a bank that actually pays an interest of 12% compounded, and then the time period is actually 4 years. So if you were to calculate this, you can come here and you say that amount, which is 120,000, should be given by the principal, which we don't know, into 1 plus 12 over 100, then we raise to power 4. So 120,000 is equal to, remember 12% is the same as 0.12. 0.12 plus 1, it is going to be 1.12 power 4. If we raise that, if we raise 1.12 power 4, 1.12 power 4, we realize we get 1.5735. So 120,000 is going to be equal to 1.5735x. If we divide now by 1.5735, both sides, 15735, then we should be able to get our x. So 120,000 divided by the answer is going to be actually our x, and we realize that our x is equals to 76 to 62.17. That is actually the principle, and you can be able to get it like that. In some instances, from this formula that amount is given by the principal into 1 plus rate over 100 power n, you can be asked also to calculate the rate, given that you are given the amount, principal, and the time. Like for example, if you are given that the amount is maybe 25,000, you are given the rate is 7%, and now the principal is maybe 15,000, you are told you calculate the value of n, which is actually the time period. Remember, this n is a power. This n is a power. And to bring it down, we need actually to use the rows of logarithm. But this is how we are going to do it. If we substitute these values that were given in the formula, we are going to find that amount, which is 25,000, will be equal to the principal, which is 15,000, into 1 plus the rate, which is the same as 0.07, that is 7%, and then we raise this to power n. So the first thing you'll be able to do is to divide both sides by 15,000 so that we remain with this part. So we are going to have 25,000 over 15,000 is going to be 15 into 1 plus this. We can just go straight and put it as we can just go straight and put it as 1.07 power n. This is actually 15,000, and then we divide by 15,000 because 15,000 is dividing both sides. So this 15,000 and this 15,000, on this side we are going to remain with 1.07 power n, whereas on this side we are going to have 25,000 divided by 15,000, which is giving us 1.667, 1.667, like that. So One thing you'll be able to realize that anytime we have this power, for us to be able to work it out, we need to introduce logarithm, and we have got the third row of logarithm that says if you have log a power n, it can be written as a n log a. This is the third row of logarithm which we need to apply here. So we can come here and introduce log to both ends, and we say log 1.667 is equals to log 1.07 power n. We have introduced log to both sides. And one thing you can be able to realize that this side, it is the same as actually what we have here, where we have log a power n. In this case, our a, it is 1.07, and therefore it can be written as this. So we can come here and we say log 1.667 is equals to n comes now in front here, log 1.07, like that. Therefore, we can say log 1.667 over log 1.07 will give us our n. I've just divided both sides by this so that we can remain with n on this side. So log 1.667 divided by log 1.07 will give us actually 7. N is given by 7.6. It will take around 7.6 years for this amount to accumulate to this amount after or with this rate of compound interest. So one thing I want to emphasize here, that whenever you are actually looking for n or working out for n, you will have to introduce logs so that now you can bring this power down here. There is no way out. It must be introduction of logs so that now we can apply this third rule anytime we are calculating n. I want to stop there for today, and I hope now you can be able to interact well with this particular compound interest formula for you to be able to get any value that it is not given, be it the r, be it p, be it n, be it a. Any value that you are not given in that particular question, you can be able to substitute and have it. But note, the n is always going to be to attract actually the logarithm. But I've just remembered we have not calculated r. Let us see how do we calculate r when it is not given. Let us have a simple example whereby you are given amount is 50,000. You are given the principal is actually 25,000. You are given, you are not given actually the rate, and you are given n, it is 4 years. Then you are asked, calculate the rate, which is actually the compound rate of interest that will make this amount of money to accumulate to 50,000 after 4 years. Simply come here and say, amount is given by principal into 1 plus r over 100 power n. In this case, our A is 50,000, must be equal to 25,000, must be equal to 25,000 into 1 plus the rate, 1 plus r over 100 power 4. We don't know the rate here. So we can simply divide 25,000 on both ends, so that on this side, if we divide by 25,000 and this side by 25,000, this 25 and this 25 will cancel out. 25 will go to 50,000 twice. So we are going to have 2 is equals to 1 plus r over 100 power 4. Now, somebody might ask again, how are we going? Remember this, whatever we have in this bracket, it is actually tied with this power. There's no way we can remove this one from here because everything, it is supposed to be raised to power 4. Whenever you are in this particular step now, you need now to remember something. When we are talking about maybe 9 is equals to x squared, what do we normally do? we normally take the square root on both sides, so that we can say that 9 is equals to x. Root 9 is equals to x. In this case, we know the square root of a number squared is actually the number. If, for example, we are having something like this, you are given that 27 is equals to x cubed. What do we normally do to get x? We normally get the cube root both sides. Again here, the cube root of a number cubed, if you take the cube root of this number that is already cubed, you just get the number without any power. So, and then you work out this and you find it's going to give you 3. Similarly here, if you are given, like for example, you are given that x is equals to maybe x power 4 is given by, maybe we talk about something like what? Something like 64. You realize that for us to be able to get this, we need to get the fourth root on both sides. We get the fourth root on both sides. So this is actually the concept that we need to apply here. For us to be able to work out this, we need to get the fourth root of 2 and the fourth root of 1 plus r over 100. Because this one, it is already to power 4. This one is already to power 4. A number, the fourth root of a number that is raised to power 4, it is that number without the power. So if you get the fourth root of 2, the fourth root of 2, you just get it this way. You press 4, shift, there's that button on your calculator whereby we have the value of x on indicator on it. Actually, there's a button that we have, and on top here, it has got this sign. It has got this sign. So you shift, you press 4, shift, and then you press this button, whereby on top of it, we have the cube root of x. So what we need to do here is to press 4, then shift, then we press this particular button that is adjacent to that. We shift, 4, shift, we press that button, and then we press 2. That simply means that the fourth root of 2 is equals to what? We get that it's going to be 1.189. Therefore, 1.189 minus 1 must give us r over 100. You find that 0.189 is equals to r over 100. So 18.9% is going to be r. 18.9% is going to be r. But you need to remember this concept very much. If, for example, this one was raised to power 5, we could have calculated the fifth root of 2 on each side, so that now we are going to have 1 plus r over 100 without power 5. If it was power 6, we could have obtained the sixth root on both sides, so that here we remain with 1 plus r without power 6, like that. And how do you solve this? You just press. If it was power 5, you press 5 on your calculator, then you go to shift, then you press the button. Actually, the button that is having this sign here, it is the button for the raise to. So you 5, shift, you press this, so that you can be able to access actually the manipulation of this, and then you press the number that you had here. So if, for example, you had maybe 3.5, you press 5, shift, this button, and then you press 3.5, so that actually you can get the fifth root of 3.5, like that. Thank you very much, and you should be able to work out the examples that I'm going to provide.